Welcome to my talk, Rag and Route, Enhancing Networks to Support Amazon Bedrock. I know it says sponsored by Aviatrix. I am not here to sell you anything, so if you're looking to buy, you'll have to go to the expo. My name is Tim McConaughey. I am a technical marketing engineer at Aviatrix. I have a CCIE in routing and switching, and an AWS advanced networking specialty. I am an author of a book called the Hybrid Cloud Network Handbook for AWS. And we're about to release a new ANS certification guide through Pact Publishing with a couple co-authors. I also have a YouTube channel, a blog, probably a breakfast cereal somewhere. I don't know. So let's talk about our agenda. What are we going to learn about today? So we're going to go through what is RAG, and then, of course, what is Bedrock, and then talk about the networking challenges of using both of those. So I've done about half for the developers and about half for the network engineers so that I can equally annoy both of you. All right. So let's just start with RAG. What is RAG, and what does it mean in the context of generative AI? I'm not going to spend a lot of time on the large language model part of it, because I think everybody by now has probably tried ChatGPT and understands what an LLM is. But let's set the stage and get the context of how RAG and LLMs have something to do with each other. So let me introduce you to the original LLM. So the original LLM was basically like printed encyclopedias. Who here is old enough to remember working with printed encyclopedias to do book reports? Okay. So they're not entirely out of fashion, or I just have a very wise audience. However, yeah, so you get the idea, right? So encyclopedias are treasure troves of information, animal, vegetable, mineral, A to Z. They're collated, they're collected. There's a lot of data that's pulled together and put into essentially a model that can be consumed by people looking to, say, write a book report on dinosaurs or something like this, right? It's full of topical facts, figures, and by the time you open your own encyclopedia, it's already out of date, right? It's years, potentially months or years out of date. So just like large language models, is there anybody, I'm sure everybody here who has asked ChatGPT or Claude something like, what happened XYZ date, and it says my language model only goes to August 2021. Something like that, right? And that's because of the way a large language model is trained based on data on a certain subset. So let's talk about the original RAG. Sorry, this is a bit of a dad joke. So we used to call magazines rags, sorry. So think about what RAG is in this context. So in the context of encyclopedia that takes months or years to put together, and by the time you're reading the encyclopedia, it's already out of date, a RAG, or a magazine, is more like something that's released periodically. So we're talking about, like medical journals, National Geographic, Smithsonian, right? That's coming out every few months, and it's got new topics, it's got new data. Going back to the idea of writing a book report on a T-Rex, that's going to have an article about how T-Rex had feathers, for example. So that's going to have data that the encyclopedia is not going to have, and it's going to be useful in the context of, say, writing a book report about a T-Rex. All right, so let's talk about what retrieval augmented generation means. So retrieval is the act of fetching the relevant context. So what I mean by that is when you're creating a prompt, or your application or AI agent is sending some kind of prompt or query to a large language model, you're saying like, tell me everything about T-Rex. What the retrieval part of RAG will do is go into the data and find the relevant context for, say, about T-Rex. So, using that same analogy, it would find the National Geographic magazine with the article about T-Rex, and then offer that up as, hey, this is relevant to the thing that you're asking about. And then, because of that, it will augment the prompt that you've created. So it's adding the relevant context, it's adding the extra information out of that data, and adding it to your original query. So like I said, if I'm writing a book report about T-Rex, it's going to add, hey, by the way, since you read that encyclopedia, T-Rex is actually found to have feathers. So that can now become part of my book report. Okay? And then, of course, the generation part of it is the book report. It's the output. It's what comes back out of the large language model and is given to you as the book report. So let's walk through now, like, okay, so that's high level what RAG is, where it fits into the LLM model. Now let's kind of walk through the pieces of RAG and how they work. Okay. So from creating RAG, we're talking about, so RAG is actually composed of multiple elements, right? So there's a data source, there's an embedding model, and then there's a vector database. So these are three pieces. They're actually standalone solutions on their own. They can be used for many, many things. But when you put these things together, we get a RAG solution. So the first thing we do is, of course, we're going to load our document or relevant National Geographic or whatever into a data source. And a data source is just what it sounds like. It's a NetApp file server storage, an S3 bucket. It could be Google Cloud storage, whatever it is. It's some kind of storage where you're putting data. Now, the embedding model is interesting. So just like large language models have, training data and whatnot, so embedding models have the same thing. But they're focused on actually tearing apart documents and media and turning it into chunks of data. So they do a process called chunking. So if I feed my book report or something, or my National Geographic into an embedding model, it's going to chunk that article and create pieces of text, pieces of meaningful data, and just turn them into chunks. And so the end result of chunking is that it's going to then load and put the vectors, what they're called, they're like mathematical representations of data is what a vector is. And they're going to take the vectors, and they're going to insert the vectors into a vector database. Okay, so you're taking the math, you're putting it into the vector database. It's an index type of thing, like all the databases that you can search for. And now you've got data, little chunks of data that are mathematically, they use a mathematical algorithm to make these vectors, and now you have access to them. And you can use them for your RAG solution. So let's put this in context of a whole query pipeline. Okay, so first we'll just step through the parts we already talked about, right? We're going to load a document into our data source, and from our data source, we're going to take it, we're going to chunk it in the embedding model. And there's a bunch of different embedding models, by the way. There's embedding models that focus on sentences, there's ones that focus on topics. There's a lot of math involved, and honestly, somebody smarter than me would have to explain that. But ultimately, what you get is a bunch of vectors that get loaded into a vector database. Okay. Now let's go to the other side. Now we're going to actually make a query. So it says user query, but this could also be an AI agent. This could be an application. This is some request that we're making of the large language model. Okay, and that query actually is also going into an embedding model. Now, these don't have to be the same workload, right? The embedding model, it doesn't have to be the exact same workload in AWS that's running the embedding, but it does have to be the same type of model. So if you're using a specific sentence embedding model, you need to use the same embedding model when you do the query. It's kind of like a decoder ring type of situation, because the vectors that are going to be produced from the query are going to need to be similar to the vectors that are in the database. So what comes next is it's going to do what's called a similarity search in the vector database. The query will be compared against all of the vectors that we have. And remember, the vectors are just stand-ins for that data, that relevant data that we're talking about, okay? And then together, we're going to pull out the relevant data. Now, they compare the vectors to a certain mathematical degree. It's configurable. Again, someone smarter than me would have to talk about it. But the ultimate thing that you get out of it is that you get your original query plus the relevant data that's pulled out of the vector database, and all of that is fed into an augmented prompt. And that prompt is actually what we're going to end up sending to the large language model. And because we've added all this extra data, this stuff that the language model doesn't already know, when we generate, we get that reply back, what we're going to get is a much more interesting, much more contextual, factual, up-to-date, better reply. All right, so now we understand, okay, here's RAG, here's how it fits into the LLM model of queries. So let's introduce and talk about where Amazon Bedrock fits into this solution. Okay, so Bedrock is a fully managed service from Amazon, and it provides a front-end API to consume large language models on the back end. Okay, so if you think about it, this isn't the kind of thing where someone is standing at their computer, sitting at their computer, sorry, typing into the Claude or ChatGPT front end and sending that off and trying to get an answer back. This is like application focused. This is a front end API. So Bedrock is that front end API that Amazon has built that lets you interact with a bunch of foundational models that Amazon has, essentially access to. You can choose which models you want to use, but you can have this front end API that you can just develop for just the API. And the Bedrock API is that method of sending queries to the foundational model. And where RAG fits into this is that RAG can be part of that whole process where we're sending front end API calls to Bedrock on the back end. And Bedrock has other capabilities, like you can make AI agents and whatnot, but I'm going to focus on what we're talking about today. Okay, so within the context of Bedrock, we also have something called a knowledge base. Now, a knowledge base is an Amazon-specific term for a managed RAG solution. So if you go to the Bedrock UI, you can start a knowledge, or you can create your own knowledge base, right? And what that's going to create for you is a fully managed RAG solution, but it's based on predefined data source, embedding model, vector database. It's like a drop-down type of model where you're going to choose what Amazon supports and is made available for you to create your RAG using. Okay, so that fits a lot of people might find that fits their need and that's enough for them. But, for example, what if there's an embedding model that's out there that's usable and that fits your company's data very well, but isn't available as part of the Amazon knowledge base, or sorry, the Bedrock knowledge base? What can you do? And the answer is that, you can actually create and maintain and build your own RAG solution. There's no requirement that you use a managed service from any of the clouds, actually. So remember how I said earlier, the data store, embedding model, vector database, those are all standalone solutions. Those are things that exist outside of the concept of RAG and have existed. But you can, a data source is just a data source. It's a NetApp file share. It's an S3 bucket. It's Google Cloud Storage, right? An embedding model is a model. It's an application, right? So you can run that anywhere you can run applications. And of course, a vector database, it could be any kind of database that supports vectors. So a lot of people, a lot of businesses find that the knowledge base works for them and it's enough. But a lot of other businesses find that their specific business data is kind of shoehorned into the knowledge base model. So you need the freedom to democratize your data. So now that we've talked about basically, okay, we can create our own RAG solution, we can put it wherever we want, there are some networking challenges that are going to come when we start disaggregating and pulling apart our RAG solution and making all the pieces run where they run most advantageously for the business. And this is where we're going to get into the networking part of it. Okay. So if we're going to run a RAG solution pipeline and have our pieces disaggregated, there are certain things that the network has to do. It has to be performant, right? So we have to be aware that our data needs to be secure while in transit. Okay, that means that, think about the purpose of RAG, right? The purpose of RAG is to contextualize data, to offer more useful, timely, better information so that the generative AI, output that you get back out is better suited for what you are trying to get, right? So think about a company that wants to use proprietary data, and they want to use that proprietary data, in the concept, in the execution of getting stuff out, back out of an LLM. You need to have that be secure, right? Wherever that data is coming from, whether it be on-prem, internet, S3 bucket, in another cloud, wherever it's coming from, that data has to be secure while in transit, because it could be proprietary company data. So with that, we also need timeliness for our data delivery. When I mean timeliness, I'm talking about, we all know that applications live and die by the microsecond. That includes the ability to get those vectors, to load our stuff into data stores, to do that entire solution pipeline. that has to be really, really fast. We have to be able to be performant, and that's on us on the network side to make sure that no matter where these pieces are, that they're entirely performant and they're fast. And then, of course, this one has like a little bit of an asterisk. You may or may not need to regularly refresh your data, right? It depends on what you're trying to do. So, for example, if you have like a customer relations management app, like a CRM, and maybe you've rolled out some new feature, some new product, and you're trying to gauge how customers feel about the new product, and there's some way to track that sentiment, what you might want to do is, refresh that data in your data store very, very often so that you're tracking a trend and you're getting new output. Maybe it's even making recommendations on what should we do with this feature based on the customer feedback. And that requires regular hydration and refreshing of that data. So that's another thing that could be required as part of your RAG pipeline. Okay, so the answer, of course, that 90% of people may feel like they can use is that they could just use an S3 bucket. So S3 buckets do check all of the boxes for this. So an S3 bucket has TLS encryption. So you have application layer encryption for security for data in transit to and from an S3 bucket. S3 is also able to be used as a data store for Amazon Bedrock knowledge base. It's a built-in, out-of-the-box solution. Or you could use it for a custom RAG solution as well. There are ways to speed up the processing of an S3 bucket, right? We can use transfer acceleration, we can do multi-part uploads, we can use AWS Direct Connect with a public VIF and load it straight into an S3 bucket with a 10 gig circuit, right? So we have lots of ways to make S3 fast. And keeping data refreshed and up to date, that's as simple as scheduling your transfers, right? Just have your application regularly dump or load from an S3 bucket. It's very, very simple. And getting data to S3 is also very simple, right? Where are we sending data to? Where's data moving from to S3? So we're bringing it in from other AWS regions and VPCs, right? So we could have ETL, extract, transform, load type of workloads that are massaging or changing data, and then as a result, they're reading from or pushing into S3 buckets just regularly, right? We can do that with an S3 gateway. We could move it through transit gateway. We have and then ultimately to an S3 gateway somewhere else. There's lots of ways to move data within AWS to an S3 bucket. We could move it from on-premises into the cloud, into S3 directly, right? Like I just said, we could use an on-premises data center, or we could use a middle-mile carrier-neutral facility like Megaport, Equinix, something like that, colo data center. Wherever we can pick up an AWS Direct Connect, we have the ability to make a public VIF and connect to S3 directly. And then, of course, we can move it from other clouds, right? What if we have data? What if AWS is your second cloud, and a lot of your center of gravity is in Azure or Google Cloud or somewhere else, but you've got data that you don't necessarily want to do a lot of data transfer with, but you want to move it to an S3 bucket. That's it's basically an internet connection, right? It's just making a connection from your workloads or whatever in the other clouds to your S3 bucket. So lots of ways to get data into the S3. All right, now there are some drawbacks. There's some reasons that you might not use S3 for this purpose, right? And so one of them is, one of the big ones is that, of course, transfer acceleration, direct connect VIF, public VIF, they're costly. They have cost implications associated with them. You pay for convenience. That's always the case with managed services. You're always going to pay for convenience. And then, of course, sensitive data is encrypted at rest within S3. Amazon's gone to great lengths to make that clear, and it's true. But there are some regulated industries that still restrict what kind of data we can put in an S3 bucket. I don't know if we have anyone here who's in one of those regulated industries, but they exist, I promise. And so there are industries that can't put, and remember, we want to be able to access, we want to be able to use that data, but maybe we can't put it in an S3 bucket, right? And of course, if we're regularly refreshing this data, if we're always replacing it, just like I said earlier, the regular rehydration and replacement, that gets costly. I don't remember if it was this year or last year, but I remember reading an article about, and you guys probably have read it, you've all probably read it too, about a customer who had an S3 bucket that was locked down, but it was accessible over the internet. And so they had like a denial of service type of attack on their S3 bucket. I don't know if it was just a scanner. I can't remember if it was just a scan or not. But the point is, every time that bucket was hit, whether they got anything or not, that was a charge. Amazon was charging them for accessing the bucket. Now they did eventually like wipe it all out. They figured out it was wrong, but I mean, nobody wants to have to explain that to the business, right? So the point is though that kind of transaction, even the legit transactions, are over and over and over. So if you're using a RAG pipeline and you're loading stuff into your data store often, that could add up. So there's like I said, there's multiple reasons maybe you don't want to use S3 specifically. So let's talk about, if I can click the button, how we would build, what are our options for building our own RAG or bringing our own RAG, right? So from a vector database perspective, you can use Amazon OpenSearch. You can use a managed service, basically, at Amazon. There's multiple ones. If you look at the Bedrock knowledge bases, they have a whole drop-down with a bunch of vector stores that you can use for that purpose. You can also use a third party. Pinecone is apparently very popular as a vector database, and that's just a workload, right? You're running an EC2 instance, running Pinecone, and that's serving as your vector database. And of course, we can even use vector databases from other clouds, right? We could use Azure Cognitive Services. If we already have a center of gravity in Azure, and we're already doing AI stuff with, say, OpenAI or whatever, why reinvent the wheel, so to speak? You can use that. So from an embedding model perspective, again, there's a lot of embedding models out there. There's a lot of ways to chunk data and like pull stuff apart and make it useful and meaningful. So Amazon has their own. They call them Titan. And if you use a Bedrock knowledge base, they'll be in the dropdown of that. But you can actually use them without knowledge base as well. They make them available. You can use a third party like Universal Sentence Encoder, or again, you could use a different cloud's managed embedding model service like OpenAI service. Okay? And then from a data source perspective, I mean, data source is probably the easiest one for any of us to understand, right? It's just file storage. So you could be using a managed service like AWS, Amazon FSx for NetApp ONTAP, or we could be using our on-prem NetApp still. Like that data could just be living on-prem and never make it to the cloud. Or we could be using a third-party cloud like Google Cloud Storage. So here's the thing. If our RAG elements can be anywhere at all, how do we keep it all connected? And how do we make sure that it's secure when it's connected, when it's all connected together? All right, so I'm going to jump into the Aviatrix part of this and talk about how we at Aviatrix think is the right way to do it, but really it's applicable across the board. So before I get into this specifically, I do need to take a minute just to talk about Aviatrix, just because there are people here, I'm sure, that probably don't know Aviatrix and don't know what we do. So it's going to sound a little salesy, but I promise I'm not here to sell. So Aviatrix is a cloud networking and security platform, okay? So our idea is we can democratize your data. Wherever it lives, whatever cloud, whatever on-prem solution you have, we can provide a single unified control and data plane, security policy, operations across all of it. So that's the idea. So we can build a cloud network that extends on-prem. We're very big into hybrid cloud, where we do single or multi-cloud. We can just provide a single experience that, because you're getting that single experience, you're also able to improve your security posture because you have a single unified security policy that can be enforced anywhere. And we find that some customers, once they've built an architecture using Aviatrix, they can potentially save money on the data transfer and other ways. Okay, so this particular use case is our high performance data center edge use case. We have multiple use cases. We actually provide an entire platform. We do a full cloud platform, but we find that the best way for customers to start is to actually just build a little bit of something based on their needs, right? So we provide this as a way to democratize your, how you use LLMs. So let's move on here. Okay, so and then the last Aviatrix specific slide is that we do single cloud, multi-cloud, hybrid cloud connectivity, same control plane, same data plane, SDN focused. So agile experience, Terraform, you can automate the whole thing. And then because we own the data plane, you can get observability to the data plane. And observability is something that we find is sorely lacking in a lot of the cloud solutions. And just so, and when we're building applications that need to be, secure and they need to be performant, and we need 5 nines of uptime, what we find is that it's hard to do that in the cloud. The cloud was originally built as an agile development platform, right? It was a playground. And I know I hear from developers all the time, I came to the cloud so I wouldn't have to manage infrastructure. And that's true, right? Developers generally don't have to manage infrastructure anyway. But when we're building business critical applications in the cloud, right, it's not an agile playground anymore. Like the cloud has evolved beyond the point where we're just doing prototyping. And we still are doing prototyping, right? We're still doing all of that. It's much easier for dev teams to build a VPC and workloads and all of that, or just use a serverless development platform than to go to the infrastructure team and build out infrastructure and wait for the infrastructure to be built and everything. That's all still the case. But when solutions architects and developers have then built this application that's going to be put into production, what are we going to do? We need to have resilience. We need to have as close to 5 nines as is possible in the cloud. And so that's where things start to generally fall off a little bit. And so that's something that Aviatrix is very good at providing. All right, so let's get back to RAG. Okay, so we want to support RAG with our on-prem data sources. So again, the idea is we can democratize the whole thing. We can take elements of your RAG and we can disaggregate them, right? This is what this allows us to do, or allows businesses to do, is to take the elements and run them where they are most advantageous, or where the governance and the policy, security says, hey, we have to use, we have to use Azure for XYZ, and that becomes kind of a constraint on the way we design our networks, right, and the way we're building our applications. And ultimately, it could be a constraint on using, say, a RAG pipeline. And a RAG pipeline is just really an example. Excuse me. So now there's a requirement, though. When we start disaggregating, remember, the cloud is about loose coupling. That's how many times anybody who's ever looked at the AWS well-architected framework, the cloud is about loose coupling. So loose coupling means we're pulling the pieces of the application architecture apart, and that, it implies that there's now a requirement that we have the best possible network experience between all of the pieces of our application. And that, RAG is no different. So we could have, say, Bedrock and AWS. We could be using on-prem data sources. So maybe we have a NetApp on-prem, or something like that, because we don't want to move that data to the cloud directly. We don't want to put it in an S3 bucket. And then there's other clouds, right? Like it could be, again, Azure Cognitive Services, whatever. We can pull it all apart. So now, again, we need the high performance, and we need to do high performance. And so what we're going to do now is kind of understand the problem. One of the biggest challenges associated with doing this is that, if we're going to make it encrypted, we have to deal with IPsec bottlenecks, okay? So there's a throughput bottleneck associated with the IPsec technology, and of course, IPsec being the VPN technology, right? So for software-based IPsec solutions, a single IPsec tunnel it has to be tied to a single CPU core, and that means that the maximum performance we can get out of a single IPsec tunnel is pretty low. This says 1.25 gigs. Based on the cryptographic encryption algorithm, we can actually push it a little bit closer to 2 now. I think with GCM encryption, we can get it closer to 2. But again, that's, we're talking about direct connects where we might have 10 gig circuits, and that's just not okay. So again, it's because virtual routers have a tie between the CPU core and number of IPsec tunnels. Now you can get around this, right? So there are other third-party, there are third-party network. Sorry, a second, I need a drink. There are third-party network vendors that do this by having you spin up multiple IPsec tunnels. excuse me, and then set up the load balancing, build some kind of load balancing, some kind of routing, whatever that looks like, so that we can build multiple manual IPsec tunnels, and then they have to set up the load balancing algorithm. And I said by they, I really mean us, the network engineers, have to set up the load balancing algorithms to kind of load balance and make sure that our application can get the full amount of bandwidth. So what Aviatrix does in this case, actually, we have something which we call high performance encryption. So this is a patented technology that we have. And because we have an Aviatrix controller, an SDN controller that manages the whole control and data plane, this means that anywhere we have infrastructure, we can automatically do this. We can build 5, 10, 20 more IPsec tunnels, multiplex them all, and actually handle that application load, and so that we're intelligently routing your traffic in a way so that you can be encrypted and still get the full line rate of whatever circuit is that you're using. So, and again, like I said, it's proprietary, and it has to do with us being able to manage all of the appliances, manage the CPU cores, and just map and multiplex all of those IPsec VPN tunnels together. So this is kind of our design pattern, and we have multiple design patterns. This is the one we kind of recommend for what we call a data center edge. And this would be like if you have a direct connect delivered to your data center, and that direct connect could be connected to an edge router of some sort, like a Cisco, Juniper, whatever that is. And then our box, our Aviatrix edge could sit behind that in path as part of this. And then up in the cloud, we have VPCs, what we call transit VPCs, just I think AWS uses the same terminology, where we're using Aviatrix transit gateways. And the goal here is to create that IPsec multiplexed connectivity between our on-prem, using the direct connect, to Aviatrix in the cloud, and get that line rate encryption. So in this diagram, we are using a third-party router to actually terminate the direct connect, but we are more than capable of terminating that as well. Also, the Aviatrix Edge can be a physical platform, or it can be a compute platform. So we support both. The IPsec data plane is actually what is going to be doing all of the data transfer. We're actually only using the DX and the DX gateway to establish connectivity between our endpoints, between the Aviatrix Edge that's in the data center and the Aviatrix Transit Gateway that is in the cloud. So this means that we can also overcome route limitations. So the DX gateway, for example, has I forget what it is. It does keep changing, but it's a very low amount of routes that you can actually advertise to a direct connect gateway and have that end up being advertised to VPCs in the cloud or a transit gateway or whatnot based on where you're landing your VIF. So that lets us overcome those limitations. So, and then we also have the same pattern for carrier neutral facilities. So the carrier neutral, again, is third-party colo. So Megaport, Equinix, whatever kind of third-party colo where we have the ability to deliver private circuits, right? An AWS Direct Connect. So you can run with Equinix and Megaport. We're partnered with both of them, and you can actually, from the marketplace, spin up the Aviatrix Edge straight from the marketplace and provision the circuits in minutes and have a Direct Connect connected to the Aviatrix Edge, and then the other end of it connected to the cloud, and just have the entire thing up and running at line rate 10 minutes. So it's quick, it's automated, it's easy. The middle mile to cloud uses high performance, again, in minutes. So we can also do this with the internet. If you're as a backup connection, we can do this. This same design pattern works for internet. Now, of course, high performance encryption is going to be variable over the internet based on the size of the circuit and all of that, and it's not as reliable, but it's a good backup link if the circuit goes down. All right, so let's go through the packet walk of like what this looks like. So we're getting deep into the network engineer nitty gritty here. So this is to establish the data plane. Again, this is just explaining how we're gonna get the IPsec data plane up and running. So first thing we're gonna do is advertise from our Aviatrix Edge to the Direct Connect gateway or through the third-party router in the middle, depending on how that's going to work. we're going to send a BGP advertisement of the edge's endpoint IP. So the IP that we're going to use to build an IPsec connection. That's the first part. Okay, now once we've advertised that to the Direct Connect gateway, the Direct Connect gateway is actually going to take that IP and it's going to advertise it up to the VGW that is attached to the Direct Connect gateway. And that VGW, that virtual gateway, is also attached to the transit VPC where the Aviatrix transit is sitting. So that IP for the on-prem edge will end up in the routing table of the VPC where we have our Aviatrix transit. Okay, and at the same time, because the VGW is attached to a transit VPC, it's advertising the VPC CIDR down to the Direct Connect's gateway, which is going to use BGP to advertise it down to the edge. Okay, and that's it. Now we have two-way reachability between the transit in the cloud and our on-prem edge. And then because of this, the IPsec endpoints are now able to communicate, so now we can now send IPsec packets, and we have that IPsec tunnel VPN or multiple VPNs built for the high-performance encryption between all of our components, just using the Direct Connect as the middle, essentially, providing transport for us. All right, so let's now talk about, now that we've got this multiplexed VPN, the high-performance encryption set up between the cloud and the cloud and the on-prem, what does that look like when we send data into the cloud? So now we're going to send it from the unencrypted side, so the LAN side of our data center, the switch, whatever that looks like. It's going to come into the Aviatrix edge, where it will be encapsulated in IPsec, per flow, whatever that looks like. Again, we're multiplexing all of our flows. It's going to go over the Direct Connect, and then ultimately, because it's going over the Direct Connect, the other end of it is going to land on our Aviatrix transit in the cloud. Now from there, a couple things could happen, right? So once it lands in the cloud, we can hand it off to Cloud WAN. We could hand it off to Transit Gateway, AWS Transit Gateway. We could do IPsec VPN to other VPCs. There's lots of options from there, right? So our transit is fully compatible with basically any native cloud connectivity you probably could think of. We also do have the ability to do full platform play where it just hands off to another Aviatrix gateway that sits with your workloads and gives you full end-to-end encryption. It just depends on what you're looking to do. And we generally recommend that we don't try to, we're not going to try to rebuild Rome in a day or re-architect everything at once. We're really interested in getting you connectivity from on-prem to the cloud to support that RAG pipeline very, very quickly without having to blow away and change your architecture. All right. So what if we want to do this with multiple clouds? What if we want to use this design pattern and we want to move data between our clouds? Like I said, we can have our embedding model in Azure and we have our data on-prem and we're using Bedrock. We have to get all that talking. Well, the good news is because we provide that unified experience, we also provide a unified experience on how to connect to multiple clouds. So the design pattern doesn't change. So if you're connecting to Azure, if you're connecting to Google, Alibaba, whatever that looks like, the design pattern itself is the same. And it's all orchestrated, right? It's orchestrated by the controller. And that is really important because one of the most difficult things that network engineers deal with when talking about cloud networking is hybrid cloud networking, either on-prem to cloud or between clouds, right? It's one of the most difficult things we have to do as network engineers. There's a lot of manual effort involved. And so, the way we do it, the way we feel is the right way to do it, is to use the same kind of pattern and architecture and let the controller just handle that part of it, right? You as the network operator, you as the network architect are still doing all of that architecture. You're still getting the visibility and everything. You're still doing all of it, but you're handing off the part that honestly kind of sucks. So because it's repeatable, it also means that when we move between clouds, these carrier-neutral facilities or your on-prem facility, they become transitive. And you actually pay less egress fees using the private circuits. So if you want to move data from Google to AWS, normally you're paying hefty egress fees coming out of Google. But with this type of pattern, you actually are just paying smaller egress fees. You're coming out of the cloud, but you're using their private circuits. And then you're hitting, an Aviatrix edge, and you're moving right back up over a private circuit. So you're getting the speed, the security, and you're paying lower fees to do it. So that's our design philosophy, if you will, for how we see as the right way to build and connect multiple clouds together. All right, so this is all great, and high performance encryption, security, these are good things, right? But if you've never seen this type of solution before, it may seem pretty complicated. Like there's a lot of work to do to get it going. And so what's the real benefit from it? So there's more that comes out of it than just high-speed encryption. So the first thing is you get a uniform experience. So what that means is that whether you're in Google, whether you're in AWS, Azure, pick another cloud provider, the experience of networking is the same. That's the part that matters. And you really want that as a network engineer. You don't want to have to learn all of the little tricks and tips for every single cloud. So that's really important. Because we own the data plane, you can have that advanced visibility and troubleshooting, right? So think about it. You can do packet dumps from the gateways at any point. Anywhere that we are part of your data plane, you can do packet dumps. You can see, you can get full visibility on the traffic, and you can just see, like, what is my network doing? And the application owners can even see, what is my application doing? How is it moving across the network? Is it fast? Are we driving packets? Whatever that looks like. And ultimately, because we own the data plane, you also get a unified and single security policy in any of the clouds. And what that means is that, because we are in the data plane, again, we have the ability to enforce security wherever wherever security needs to be enforced, right? Wherever we have a presence, you have the ability to build a policy, and that policy can be enforced anywhere. And so you build one policy, and it'll be the same in Google as AWS, as Azure, or it can be different. We actually have a lot of cloud-aware stuff in our policies that lets you choose kind of, okay, well, if it's coming from this region, I would like it not to be able to talk to this region because I don't want to pay the regional transfer fees. Like those are options. Those are things you can do with using security policy. Okay, so the other thing is that network insights help you understand how your network is performing, right? Just like it says. So, we partner with Grafana, we partner with New Relic, so that the telemetry, the streaming telemetry out of the whole cloud network, and that includes, if we have your edge on-prem and your transits in the cloud, wherever we have presence, wherever our appliances are, we're sending that streaming telemetry to the same graphing engines that you're probably using for your other network architecture. And that's important for the operations teams so that they can understand, rather than having to go, think about when you're having problems, right? When your direct connect goes down, which of the 10 dashboards are we going to have to go figure out what happened? Do I need to contact the provider? Do I need to contact AWS? Do I need to have somebody with smart hands go into my colo? There's a lot of questions there. So we do things like BGP status, the tunnel gateways, CPU metric. You can read the slide. It's all up there, right? But the point is that what we want to do is kind of empower network engineers to provide those 5 nines that the application, the business kind of requires. Okay. And then, of course, we have the ability also to protect your AI workload anywhere. So anywhere where there's anywhere where Aviatrix exists, that becomes a security enforcement point. So, we have things like distributed firewalling is kind of our philosophy. We believe that centralized firewalling is great for on-prem, where we have kind of the castle and moat approach. But we think that in the cloud with loose coupling, that a distributed approach to security is the right answer, right? So rather than paying to centralize everything, paying to pull your data towards a firewall that might ultimately drop the traffic, just secure your workloads where they are, for egress security or east-west or whatever that looks like. So you get the ability to use CSP tags, cloud, region, just all the cloud-aware stuff that you care about to do security policy. All right, let's recap. And I just have like a little soapbox, and then we'll take some questions if we have any. All right, so first of all, RAG is important, right? So RAG is not going away. RAG is actually really, really important for AI. So AI really needs the ability to pull in new data and to use it, because if we don't do it, then we're going to keep getting stuff like, oh, I don't have the answer as of August 2021 or whatever that looks like. RAG lets us give contextual, up-to-date data to the business. All right, so Bedrock, again. Bedrock is the managed front-end Amazon service for foundational models. It uses that uses an API. So we have an API that's targetable for back-end models. We can use RAG as part of that. It just lets the developers access a single API and then use whatever back-end model that they would like to use. Again, RAG pipeline being part of that. Now, for some customers, using a ready-made RAG solution in Bedrock with, say, S3 as the data source will make sense for them, right? It makes, honestly, I feel like Amazon generally aims for the 80%. Whoever needs this is good enough for them, then it works. And so for a lot of businesses, that'll make sense. But if we need granular control over the data source, over the location embedding, where the data source is, where the data is at, where our embeddings are at, where the vector databases are, we need the ability to bring our own RAG, okay? And that means that we need to be able to disaggregate it, and it means we need to be able to connect it. And so whether you use Aviatrix or not, the point is, if you're going to disaggregate your RAG solution, you need to make sure that you can build a secure network, and that's going to connect all of the pieces of your solution together to give you that 5 nines and that becomes critical to the success. So I meant to say this at the beginning, but I'll go ahead and say it now. So what I kind of want to underpin in this talk is there needs to be a little bit of a reconciliation, if you will, between the development community and the network engineering community, the infrastructure community. So what I mean by that is this. So network engineers in the past have kind of cut ourselves off from the process. So what I mean by that is we have said that, whatever you're gonna, we don't care about your application because we have 500 applications to support and we don't really need to worry about your application, right? So we don't care, and we kind of go into the cave and roll the rock up in front, and we just kind of take ourselves out of the conversation. When solutions are being architected, when development's happening, when new applications are being built, we have in the past, especially in the on-prem world, speaking from experience, taken the tack that we can just step to the side. We don't need to care about how these things are built because ultimately they're going to have to run on the same network as all the other applications. And I strongly urge, if you're a network engineer, I strongly urge you to change that mindset, to have an opinion about how things are built. And the reason is very simple, actually. So when that application is architected, when that solution is built, and it ends up, okay, we've got 1 week until it goes live, how many times has that ended up, okay, here it is, go build the network for it and make sure it's you get 5 nines of uptime, and you look at the requirements and they're completely untenable, right? So that happens honestly far too often. So we need to, as network engineers, we need to start being more opinionated about applications. We need to start understanding solution architecture beyond layer 3, layer 4, right? So, and then on the development side, I strongly urge the development people to really include network engineers in the solutions architecture piece of it, right? So I know that developers kind of took the tack that, I went to the cloud so I wouldn't have to manage infrastructure. And I think that's true. Right? But again, that was because the cloud was built for prototyping, for playground stuff, right? Now we're past that. We're building business critical applications. We're putting them in the cloud, and then we're dumping them on the infrastructure people and saying, make that 5 nines resiliency. and it can't be done at that point. So, if I can't tell you how many times I've heard it works on my computer, right? Well, it works on my computer doesn't work in the cloud. So from a development perspective, we need to be more opinionated about what solution architecture looks like when we're going to do loose coupling in the cloud, when we're going to pull it all apart, but we want it to all work, there might need to be a little bit more work done there on the development side to make sure that at the end of the day, it's going to be more resilient. So I was going to say step up my soapbox, but I guess I'm already on one. And I will leave it there. I want to thank everyone for coming, and I want to urge you to complete the session survey in the mobile app. We have a few minutes left, so I will open it up for questions if anybody does have questions. And please, if you haven't connected with me yet, please feel free to do so. I have a blog. Connect with me on LinkedIn. Follow me on Twitter, whatever. And yeah, thanks.